into employees. For example, you have to say employee ID, and then you list basically all fields, values. And the values will be as shown here, 207, and then tester, and so on. Okay, so now it's very easy for you to correlate, saying employee ID is this one, and this field, second field is this one, and so on, exactly as is. And this value should be listed exactly the same order as field names. Okay, exactly as is, because we don't have a possibility to specify saying 207 is kind of an employee ID here. Okay, we can have this one, but this is not guaranteed that order is correct. Okay, so you have to be very careful.
If it is wrong, it will give an error, or it will take it as a
if the data type matches and the value length is okay, you'll get inserted, but it will be incorrect. Okay, you'll actually, that's what will be bad. You have data corruption. So you have to make sure. But if the data type is incorrect, definitely you'll get an error when you execute this statement. Okay, and now if auto commit is checked in, assuming that you're executing this statement, don't do that. Okay, because I was pretty flexible before until people started to execute that and added additional employees, and then they screw up the database. So essentially, when you do these statements, please make sure that auto commit, when you are going to play at home, please make sure that auto commit checkbox, which you see on your screen, is unchecked. Okay, we are going to cover auto commit in a sec, but do that. Okay, follow that auto commit is unchecked. Unfortunately, when you start a database, it's checked by default. Okay, please make sure that it's unchecked all the time. Okay, any problems with this code, with this statement? Insert. Again, just you have to visually inspect that and tell me, not execute that. The problem is the following. If we execute it once, the tester will be inserted into the database, but we're executing second time, assuming that another tester arrives, okay, then it will actually issue an error, because we will violate the primary key constraint. We cannot have two employees with the same 207, right? That will be an error. So I can try to do that if it allows me, because this, yeah, probably I would. Let's do that. Please don't do that, because to be on the safer side. Okay, so I'm going to 62. Okay, I'm going to execute this statement. So you just watch. So please don't execute yourself. Yeah, again. So I have to fix the single quotes, which are distorted, obviously. This is PowerPoint. Tester. Oh, man. I believe Human Resources HR has enough privileges of executing this statement. Let's see. I have to uncheck the auto commit, which is checked by default. So let's do that. Okay. So I inserted one row. It says one row inserted, right? So what I can do, I can say select. If I try to execute this once more, I'll get an error. It says Oracle 00, the very first error, right? 0001. It says unique constraint is violated. That's what it is. I'm not allowed to insert the same person which has the same unique ID. Okay, so this person is in a database, but I'm going to undo that. Okay, so I'm saying roll back. Okay. So this person is now roll back. What happens? Yeah. Okay. So basically, I have undone my changes. Okay, to be on the safer side. Okay, so what it means here is that we have to find out a mechanism how to eliminate these possibilities, because you know what, we cannot require that human resources will keep track of employee ID somewhere, and every new employee added to the company, that number will increment it. We have to do it we have to automate this task. Basically, we have to generate numbers automatically and make sure that these are unique numbers. So what we can do here, we can actually automate this task by modifying the insert statement the following way. Instead of providing the hard-coded value as in the previous case, like this 207 is hard-coded one, what I do, I'm getting the highest, say, maximum employee ID, I'm getting the current highest employee ID and adding 1 to it. If I add 1, I guarantee that this employee ID does not exist anymore. Okay, so in this case, it's much safer, okay, because I don't care, okay, what the current number is. I'm sure that it does not exist. And the next employee will be incremented by 1 and so on. This is actually much better, but in reality, you don't need to do this either. I mean, this is too complex for database. What you can do, you can actually create a sequencer. In Oracle, it's called sequencer. What it does is actually a number generator. Every time you can specify what numbers it should generate, and every time you need good unique ID, you say sequencer, give me an ID, okay? And sequencer will give you that ID. Okay, that's easy, much easier to do. And then that will be this format, or with using sequencer, is much more robust, because you can insert, say, millions testers. You can run this statement many times, but every time you'll be guaranteed that the tester ID will be unique. Okay, that's the only constraint, right? So you may have tons of testers with the same phone number and the salary and so on, but for database point of view, they will be different employees. Okay. Okay, so let's move forward. Delete statement, as you may assume, deletes the record. Okay, so this is the syntax for that. Delete from employees, and then you have to specify the predicate. Predicate is optional here, but consider always using it, always use it. Okay. The reason is that if you don't use predicate, you'll get all records deleted. Okay. Fortunately, if the auto check after auto commit is unchecked, you have possibility to revert it back. But if auto commit is checked in, your database will be emptied. Okay. So I got a couple of cases before when database was emptied that way, similar way. Okay. So bottom line is always use predicate here. So for example, delete from employees where employee ID is, for example, 107 or 207, something like that. So here's the example of that. It says delete from employees where employee ID is 207. So this is very robust way of doing it. Okay, because you are guaranteed to delete one record, 0 or 1 record max. If employee 207 does not exist, definitely that employee will not be deleted. But if it exists, and we guarantee that it will be only 1 employee, then it will be deleted. We can also use this statement, delete from employees where email is tt-tester. So which is the more robust way of doing it? Employee ID is is better, the first one, because we guarantee that there will be definitely 1 employee ID per employee. I've seen the cases in real life that 2 employees sharing the same email address by mistake. Okay, so if you delete, for example, if you execute this statement, there is a possibility that you delete 2 employees rather than 1. Okay, and this is the answer. That. And here you can use in operator, between operator, pretty much as we did before. In this case, we are actually deleting 21 employees. And also we can automate this task. For example, when deletion happens, we like to some other processes to start. Then what processes are, maybe send email to investors saying, you know, we actually did a headcount reduction. And also we can send email to EDD saying, you know, we had layoff, and then we actually laid off 21 employees. Also, a reverse task, which is much more pleasant. For example, if we added new employees to the company, we can automate a task like sending email to IT department, right? Saying, you know what, next month we start, say 21 employees started our company, please order 21 notebooks or laptops, whatever. Okay, so that can be also automated, because if company is big, no way you can do it manually. Okay, you should automate this process. And this is possible to do using the triggers. Okay, there are triggers, basically mechanisms which allow us to automate these processes. Another way of deleting data is truncate command. Okay, so truncate command will delete content of the table irreversibly and delete much faster. Okay, so the difference between delete and truncate is following. When you issue delete command like shown here, delete from employees where employee ID 107 and 107, what happens is that a database engine goes record by one from top to the bottom. When it finds a record which satisfies this condition, it deletes that. But nevertheless, it traverses from the top to the bottom. When you say truncate command does not accept any predicates. Basically, you don't need to specify anything, and you cannot specify anything. When you say truncate employees, it will go just basically dumps all values into the trash can without going record by record. So it's faster because it does not care about records. Whatever it finds, it's immediately trash everything at once. Now, truncate is not reversible. It means that once you issue the command, doesn't matter how the commit is checked or not checked, you lose your data. Okay, it's a very dangerous command, and some people actually can tell the stories they used truncate command and lost their job. Okay, so the real stories behind that. Okay, be very careful. Now, the third command, but when we execute truncate command, we delete only data, but not a table itself. Okay, table structure remains the same, but simply we don't. If, for example, if I say truncate employees, I will delete all employees, but table will remain intact. Okay, if I open the table, it will contain no employees, but the structure will be there. Now, the third command, which is more dangerous than everything else, is drop command. Drop command looks like the following. If you have, for example, very nice crystal vase in your hand and walking on a concrete floor and suddenly drop it. Okay, so the vase actually crashes into smithereens and is completely unrecoverable, and you lose everything. Probably you lose water and you lose your vase. Okay, that's everything at once. That's what it is. If you say drop command, the table will be deleted with the data, with the structure. Okay, so if I'm saying drop employees table will be completely deleted from database with no traces. Okay, so next time you open database, employees table is not there even. Empty or not empty, it's not there. Okay, so these are actually three commands to delete the data, and this question is asked on interview. Okay, difference between delete, truncate, and drop. Okay, you can also drop database as well, the whole database. If I'm saying drop HR, you may actually drop that, user or schema, depending what I specify. Okay, so very, very dangerous command, and definitely it's not undoable. Okay, it's
so
once
delete, it's not undoable.
Deleted can be undoable, is potentially, yeah. If you, we are going to cover that. Okay, provided some conditions are met, but truncate and drop are not. Okay, they are reversible. But truncate is a little bit more polite because it leaves the structure intact. Drop does not leave anything, any traces. Okay, so very dangerous. So next statement is update, which you may assume that it's not inserting new data and it's not deleting new one, but basically it's updating existing data. For example, the syntax of that update is the following. You say update, we specify table name, and say set, keyword set. Set allows us to specify new value for a given field. Like, for example, update employee, set salary to 20,000 where employee ID 106. In this case, one employee with the ID 106 will get new salary, which is 20,000. Doesn't matter what his previous salary was, but his new salary will be 20,000. Okay, something like that. So when company goes public, then president may execute this statement, say update employee, set salary 1 million where job ID is at president. Okay, so he can do that if IPO is successful. Okay, so also you can update several columns, several fields at the same time. For example, you can update the salary and you can update job position at the same time within the same statement. Okay, so this is the exercise which you don't need to execute. Again, don't execute this one, but this is typical exercise. Say we have Diana Lawrence in the company, and you can find her. And she got married and definitely like to change her name, last name. Okay, her new name is now Dana Götz, should be Dana Götz. So write down the statement, but please don't execute that. Necessary changes should be made in the table, okay, in the employees table. As that. So my statement may look like this. First of all, I have to make sure that Dana Lawrence is only one person. I have to get her employee ID. In reality, in real life, Dana Lawrence will come to HR with her ID at hand. Okay, so there is no necessity, but I have to make sure that Dana Lawrence, we have only one Dana Lawrence here. If we have more than one, we have to select who is actually going to change her name. I'm saying select, start from employees, so where first name equals Dana, and last name equals Lawrence. Correct? I get employee 107, and it's only one person retrieved, so I'm pretty fine. I'm okay. I'm saying I'm not executing that. I'm saying update it employees set last name to Götz, where employee ID equals 107, right? Table of view does not exist. I'm saying employees, okay? Please don't execute that, because I know how to revert it back. Is this correct statement or we miss something? A statement is executable. It means it's correct, but do we miss something, or we are satisfied with this? Okay? Yeah, I run it, and then please don't run it. I did it, so it says one record updated. Okay, I can undo it.
That's why I cannot bring it, because
Well, which one? This one is just for self-check. This is for self-check. It's nothing. Update statement is actually missing, because if she updates her last name, she should update email address.
We need to do the first one to find out what's her ID number.
no, we cannot do that because
we
there is
didn't
no
get it.
name in the system.
Right?
You should have Dana Lawrence. It's not. It should be. She should be present in all databases.
It should be present on the database.
Yes. Okay. What we missed here is that when she updates her last name, definitely email also should be updated, right? Instead of D. Lawrence? No, that's not the case. Say because she liked to get rid of all past. So last name equal Götz, and email.
So that means that she got divorced.
Email equals D. Götz. Something like this. Because email should also be updated, right? So if I execute that, it's again executed with no problem. So basically we updated the table, but I'm reverting it back because that's too dangerous. I don't like to keep it. So I undone that. Okay, I have undone that. So that's think about that. So maybe a couple of updates is needed, not only just one thing. Okay, don't be straightforward. Just think about that. Okay, what else should be updated? Okay, so said that. Yeah, go back. One thing which is missing here also is there is a risky one, because I figured out that only the one Dana Lawrence, okay, and even if she comes with the employee ID, that's okay. We find out that her employee ID is 107, but we are not guaranteed that the email D. Götz is not in use. Maybe that will be Dan Lawrence or Dan Götz, and that his email will be Dan Götz too, right? So that will be mid-air collision. So what it means that employee table does not put restrictions on email addresses. It means that it is possible technically that two people have sharing the same email address, but it's not good. So you have to make sure first that D. Götz does not exist before executing this one. And if it exists, we have to modify it somehow, and then make sure that the Dan accepts that. Maybe we say dgirls1 or dgirls2 or something like that. Okay, or dgirls, for example, date of birth or whatever. Okay, so it's not bulletproof statement. But in other words, we have to think about that too. Okay, because about the last name, that's okay, but the email address, we have to make sure that it's unique too. Okay. Again, please don't execute that, because otherwise I will be doomed to fix the databases. Okay, so this one is what we already covered. We have slide 70, which shows that. Now we are going to turn into the joins, because it doesn't matter which company you go. If you definitely have an interview, first question will be write a statement to get employee ID based on the name, first name and last name, or getting first and last name based on the employee ID. If you successfully answer that question, the next question, the very next question, will be joins. Okay, that's 100% of that. Okay, because people like to know how much you know. So what the join operation is essentially combining, gathering information scattered across several tables into one. So what you do, you basically join these tables together and then querying these tables at once. We pretty much do similar stuff when we're using nested statements, but join is more powerful because there are situations which you cannot use nested select statements. Okay, they cannot be used in every situation. But join operation can do that. Okay, and so that's pretty much it about join. For example, what we like to do, for example, if we go to the very first example of our database, I like to retrieve, for example, Anna Razgul's phone number, but I'd like to retrieve in one statement, not in two separate statements. Or I like to retrieve physical addresses of departments and getting number of employees in these departments in one statement, not nested one, but in one select statement. So it is possible. Yeah, this is basically illustration of that example. So another example is that I like to create employee's phone book, essentially company's phone book. I like to get the first name employee, last name, and department name. Okay, so if I query employees tables only, I'll get this information because the department ID is listed in employees, but not the department name. This might be okay for old-timers, but for newcomers, this might be embarrassing because they don't memorize these department IDs yet. Okay, so definitely I like to have department names. If I query departments, I can get department names, but there will be no employee first and last name because this is a departments table. This is not employees table. I like kind of combine them together to create a phone book of the company, address book. Okay. I would like to use this format. I like to see, for example, Alan Abel works in administration, David Austin works on administration or IT, whatever, in this following format. Okay, but this information you realize is scattered across two tables, employees and departments. Well, I like to combine them together in one statement and get these results. Okay, so let's do that. In order to do that, we have to come to the following two concepts. We have to cover them. First of all, so far, when we're using field names, we didn't specify full names. Okay. For example, if we go back to our database, and I'm saying insert into employee, not this one, select start from employees where manager is null, or for example, select department ID from departments, like this one. Okay. So I didn't specify department ID's full name because I'm querying only one table, departments. Okay, and department ID is the only field with that name in departments. We cannot have second field with the same name. Okay, now if we are querying two tables at the same time, you don't have that luxury anymore because department ID may exist. Indeed, it exists in employees and it exists in the departments. So you have to be very specific which department ID you are querying. Okay, so you have to provide full name. So that's what it says here, as shown here. For example, I'm saying select employees dot first name. It means that I'm interested about first name, which is located in employees table. It might be other table like job history, which may also contain first name and last name. In that case, if I'm querying these two tables, I have to say job history dot first name. Okay, I have to use fully qualified names. You can also query several databases at the same time. In that case, you have to specify database name dot table name dot field. Okay, it will be fully qualified name. Now, this statement differs from the previous statements in not only by these fully qualified names, but also by the fact that I am. It's not completely here. Here. I'm querying actually two tables at the same time. So far, all statements or select statements which we issued were querying only one table, either employees, departments, and so on. But in this case, we are querying two tables. I'm querying employees and departments. Okay? Let's execute this statement, and see what we'll get. Okay, this is actually the beginning of join statement. Let's see what the result we'll get. This is 79. Getting 79. This one. Oh. So, getting here. I'm querying employee's first name, employee's last name, employee's phone number, department name. So I'm actually getting 3 fields from employees and 1 field from departments. And I'm querying 2 tables, employees and departments. How many records should I expect? No, you have to get the concrete number. I'm selecting employee's first name and employee's last name. It means that I'm getting all employees, right? 107, right? That number should be 107, and I should get 107 records. Okay? Now, if I execute this statement, I'm getting slightly more. I'm getting 200 records because I selected 200, but if I select, say, 100,000 records and run it again, I will get 2,889. Okay, so basically it does not make any sense, right? Because if we have 107 employees and like to select department and employees from 2 different tables, we cannot exceed number of employees, right? We cannot double or triple the size of the company within one statement, right? It doesn't make any sense, absolutely. So, can I use this? Okay. So, what happens in reality, this is expected result, okay? And the result is, a database works this following way. We get employees table with 107 records here, right? 107. And we got a departments table. I don't know how many records are in departments, but probably 28 or 30, okay? We've got 30 records here. Let's say 30. Now, when we write a statement like this, database thinks and considers that way that one employee, the very first employee, say, is working in all these departments at the same time. Okay? Then we get to the next employee, and database again saying, you know, the second employee works at the 30 departments at the same time. So essentially what you get a multiplication of these 2 tables. Okay? So if you multiply 107 by 30, or actually accurate number of departments, you'll get that 2,800, whatever we get. Okay? So this is called Cartesian results. Simple multiplication of 2 tables. Cartesian, named after French mathematician Descartes. Cartesian. Okay? So that's probably okay from database point of view, but it's not okay from human point of view. Okay? We don't expect this result, and we don't like this result. Okay? In no sense. What we can tell database is that please retrieve me employees which is matching his department ID, because when we see when we look at the employees table, we have department ID listed for that employee, right? And we can tell database, please give me that employee ID which is listed in the employees table. Basically, give me his department ID. I'm not interested in all departments because one employee cannot work in more than one department. I'm only interested in his department ID. We have to filter this, okay, result set. So that's what I'm going to do. I'm going to say and you observe here that I'm almost there. I'm getting the first name, last name, phone number, and department name. Okay, so the format is correct. The result set is incorrect. Okay, I have to say where employees department name equals department's department name. Oh, actually, sorry, employees department ID. It's not name, department ID, and this is department ID. Okay, you see here clearly that we have department ID fields which named similarly in employees and departments. It's exactly the same field name, but they're located on different tables. In order to be able to distinguish between them, I have to use fully qualified name. I'm saying this department ID from employees table and this department ID from departments table. Now, if I execute this statement, I should expect 107 records. 106 because we have null there. No, okay. We get 106 records, yeah, because employee with department null we're not taking into consideration. And you see that we're getting this, okay? So why we get executable executive, IT, finance not in ordered form, but we can order it. We can say order by a department name. Department name. We can do that. So if I execute this statement, we'll get nicely formatted phone book by department. So you see that departments are now sorted. Sorted in a formatted sorted way. But in reality, you probably like to sort by first name and last name, right? So you can do that easily by substituting this department name order by first name, for example. First name, comma, last name. Works? Okay? So this statement is looking a little bit clumsy and awkward, so I need to simplify it. What particularly I don't like it is fully qualified name is too long. Okay, say employees dot last name or department ID is simply too long. What I'm going to do is I'm going to give a nicknames to the tables, which simplify my syntax. For example, instead of calling tables employees, I call it E. And lowercase e. And departments, I call it D. Okay, so E and D are nicknames for these table names. So this allows me to simplify the statement. So whenever it's departments, I can specify lowercase d. Whenever are employees, I can specify lowercase e. It's not case sensitive. I mean, it's coding. By coding standards, it should be lowercase. Okay. Where do you have to define it, though? Sorry. Where do you have to define it? Here, departments D. That's it. And employees will be E. Okay. And again, if say E, simply much less characters to type. Okay, so it works the same way as it used to be. We'll link these two tables together. Before moving to an example to retrieve the addresses from different locations, like we did in the three nested statements, we can do that with a join statement as well. But before doing that, I would like to answer the question. I'd like to get a list of people reporting to the particular managers. We have 18 managers in the company. Like, I like to generate a list, manager ID, and people who report to that manager ID. So basically, kind of reporting for reporting. Okay, this is a little bit trickier because I have to kind of join table to itself, right? It is possible. That's called self-join. And before moving forward, this statement where E department ID equals D department ID is basically crucial. as we've already seen. Otherwise, if we don't use that, we'll get the chaos. Okay? This statement allows us to limit the number of records. And also, you should realize that the department ID, this department ID field in the departments, is a primary key here. But department ID, this department ID in the employees table, is a foreign key. Okay? So essentially, we link these two tables, departments and employees, by primary and foreign key relationship. Okay? That's why it's called natural join. Okay? Because it's nature. But that's not the only way you can join the tables together. Okay? You may basically join tables by the virtue of values they store there. Okay? So again, this seems logical and natural. That's why it's called natural join. But we also have cases of non-natural joins. Okay? So that's an issue. Now we're going to request this information from managers and employees from the same table. What I'm interested in, I'm saying select. I'm not sure what I'm going to select yet, but I know what tables I'm going to select from. I'm saying select from employees, and I'm calling it E1. Okay? And also I'm going to create another copy of the same table. I'm calling employee E2. Okay? So I'm actually, what happens is that I'm creating a duplicate of the employees table. One duplicate, one original will be called E1, duplicate will be called E2. I'm joining these two tables together. The reason I'm doing it, that from one table I'm selecting employees, from another table I'm selecting managers. Okay? So I'm saying first name, I have to be very specific here. I'm saying I'm querying the manager ID from first table. I'm saying select E1 manager ID, comma, E2 to first name, E2 last name, name from employees, employee 1, where I have to specify the predicate, otherwise I'll get a multiplication, it will blow up everything. Where E2 manager ID equals E1 manager ID, right? E1 manager ID let's see how it works. That's an idea at least. We have this. We got this list. You see that we have manager ID 1000 and the first name. That's not good. Get essentially manager IDs only. No, that's not it. So we select E1 manager ID, E2 first name and last name. That's okay. First name and last name. From employees E1, employees E2, where E2 manager ID equals E1 manager ID. How many records we retrieve? Probably more than we necessarily do. 790. Yeah, we still get a multiplication. What's wrong with this? We have to.
Multiple managers ID in each table, and they like you have for each role. I mean, you have multiple IDs with each table.
Yes.
With each table. That's why you have more than 107 records.
Yes.
They join like each other and then each other.
Yeah. Yeah.
Join them by ID, not by manager ID, by employee ID. You make them.
Let's do that. Where manager ID equals employee ID. Like this. Yes, this is correct. You see that, is it correct or not? I don't think it's correct. No, this is correct. We have Alexander Hunold is a manager ID 100. Actually, Alexander Hunold report to manager ID 100. And we get also these two people report to that. Okay. What you need to do just to verify is that also we have to eliminate the manager ID null, right? And manager ID not null. The is not null because I don't like these nulls here. Okay, so that's what we get. Order by E1 manager ID. That's what I like to see. Ordered form. That's a little bit strange, but it means that we have 4 managers' IDs. Actually, 4 managers, the majority of the company report to them. Does it make sense? I don't think we created correctly. So we're selecting first name and last name. I'm looking for employees, right? First name and last name from the second table, and the manager ID from the first table. Okay, that's okay, as saying here, stated. What we have to tell is that we say that manager ID from the second table should match employee ID from the first table. This is correct. What do you mean select all managers?
All employees who are managers.
We don't need to do that.
I mean, but I think that's what it says.
That's how we plan to do that, right? Saying manager ID should match employee ID. Because if we're selecting manager ID from the... No, that's not true. We select...
See, you have the same manager ID because you are selected on the manager.
Yes, from select...
Because that's how you join the table. And then you have an outcome on the manager.
Yeah, I'm selecting manager ID, and I assume that if I select manager ID, I get a lot of duplicates, right? If you're thinking about this one, but this is okay because if I have duplicates, it means that that manager has several subordinates, which I like to retrieve eventually, right? I'm not interested in distinct managers' IDs. That's not the point. I like to get all managers' IDs and then employees who match these IDs. The statement is correct. What happens is that what I'm actually wondering is that I have manager ID with ID 100, and this manager has a lot of employees who report to that manager. That's what I'm wondering is. But that might be the case. I don't know. Let's look at the. Let's look at the table. I'm saying select start from employee. Actually, let's do that. Select start from employees. Order by manager ID. Right? If I execute that, you'll see that I have manager 100. Yeah, that might be the case.
Yeah.
Yeah. Okay. Yeah, but we are missing 146 and so on. That's the question. How come? How can we miss this? Because if I execute this statement, I will miss some records there. Okay, your suggestion is this one? So we're retrieving employee name, first and last name from the second table, right? But we are saying that that employee manager ID, this one, this statement, that employee manager ID should match from the first table employee ID. Because manager is also an employee, right? The manager also has an ID. And then I'm selecting that same manager ID should not be null, or E2 manager ID should not be null, or maybe, yeah. Cancel. To be more exact. Yeah, that's what it is. But again,
Manager.
sorry?
I mean, it was 92 because it wasn't counting the manager.
Yeah, now, okay, yeah. Let's say is not now employee ID, E1 employee ID. Employee ID. EID. That's how it should be. Now we're getting it. Okay. That's basically incorrectly stated as, yeah. E2 order by E1 employee ID. That's correct, incorrectly written statement. So that's what we get. Yeah, now this is correct. We got employee, we have manager ID 100. It's manager ID. So this is manager ID field. We got manager 100, and that manager has, say, 10 or whatever employees here. Then we have a manager 101. We definitely can, instead of employee this manager ID, we can substitute with the first name and last name as well. Okay, and then we get this list of people reporting to him. Okay. Now again, this is done using join statement. We again got a natural join because this is a primary key and foreign key depending on each other. Okay, so basically we based on our manager ID and employee ID. Okay, so bottom line is don't hesitate to join table to itself. It is possible to do. Okay, as many times as you need. Okay, because we don't have additional tables saying managers, and everything is just basically dumped into the employees table. Again, these are examples of natural joins. The next example which I'm going to demonstrate is the following. For example, investors like to see number of employees in each department. Okay. In order to do that, I have to join two tables. I have to join employees and departments, and then group by department to get the number of employees in each department. So, but I can also do that in using group by. Remember I did that with group by? I can say, I believe I have it somewhere here. Let me see if I have this. Group by, yeah, here. Now, I execute this statement, and then I'm getting 12 records. Okay? Now, let's assume we got an audit from IRS, and they are not satisfied with these results. And they say, you know what, let's look at the company and then dig deeper. Okay? The next thing what they're going to do is just saying how many departments you have. And they assume that you should have 12 departments, right? Because that, oh, okay, 11 actually, because this is kind of a bogus department, which is null. Okay? They say, okay, let's look how many departments you have. I'm saying select department ID from departments. Thank you. Department from departments, right? Okay. Department, okay. Department. Now, if I execute this statement, I'm getting, say, 27 records. It means that there are 27 departments in the company, but only 11 are reported correctly. Okay, so we have kind of a bogus 15 departments somewhere, virtual departments. Okay. Now, and I was saying, you know what, this is not good because you have discrepancy. And the company president saying, okay, we have discrepancy, what kind of report do you expect? I can give you a number of employees per department as I used to do, right? And I get 11 departments and the number of employees. But also I can give you a report based on departments saying, you know, this is department, this is number of employees, and there is no employees, we just put simply 0. And I say, yeah, I like that. I like that idea. Okay? So, and the trick is that how you combine, how make a joint statement, because joint statement which we did for the group by statement and for address book, basically we make natural join, and natural join eliminates zeros, eliminates nulls, so we get actually employees listed for these 11 departments, okay? But what we like to do, we like to do the reverse. We like to just get the departments here, all department names. This is departments, and then make employees just either exist or not exist, whatever. Okay, something like that. So what we like to do, we like to get all records in the departments and only matching records in employees. Okay, so you see that, well, we're trying to get a full table, full left table, and only matching in the right table. That's why it's called left outer join. Okay, we like to get all the records from the left table and only matching from the right one. If you swap these tables from each other, querying this one and this one, okay, basically saying we put department table here, that will be right outer join. Okay, department depends how you put them. Okay, so left and right joins differ only by the way how you the order of tables listed. Okay, so no principal differences between them, but the meaning is that you like to get the full all the records from this one table and only matching from another one. That will be, you see that it's not natural join, which we covered. It's kind of a little bit extra, right? We like to actually cover one table completely and the second one not completely. So that's what's called outer join. That's what the meaning of outer means. Okay, so definitely there are other types of joins, but these are pretty much what it is. So let's go and look at the example of the employees in working outside of the US. Remember we did that? So using joins. We did that using nested statements, but let's do that using joins. Let's see, where is that? That was this one, right? The very first statement I have. Now let's do that. This is nested statement. I'm going to rewrite in the using joins. So what I need to do, I need to query 3 tables. I'm saying from departments, I need to query departments. I need to query employees table. Employees, department, let's type it, departments. And also locations. I'm querying these 3 tables, but in order to do it accurately, I have to use nickname. The smart way, I have to use nicknames, okay? Because they will simplify the statement drastically. See, employees E, departments D, and locations L. So I start with this specifying the tables. Now let's see what I'm looking specifically for. I'm looking for employee ID, count of employee ID, okay? Then I don't need this from employees anymore because it's already specified. I don't need department ID from departments. I don't need this part anymore. And I don't need this from locations anymore. Now let's construct the where clause. Okay, I'm saying where country ID is not US, right? I have to specify that definitely. I'm saying where country ID, but country ID is part of the locations, right? I'm saying L, country ID. Also have to specify department ID in location ID where country not equals, and departments and the lowercase l, the department. How we join them together? Let's see. Country ID. This is a valid condition. L country ID should not be in US, and department, the department, the and the location ID equals L location ID, right? Because they should match. And E department name equals the department name. Department ID actually. Let's see if it's correct. The location ID equals the location ID and the department ID equals. Let's execute this guy. Select count employee ID. So that will be E employee ID. Employee ID. This one. That's how it should look like. I get 38 employees, which is the answer which we got before. But in this case, the select statement looks much nicer. Okay, because and logically they actually easier to understand than previous nested one. We don't have multiple parentheses, whatever. What I do here, I'm interested in a count of employee IDs. That's what my goal is. Which table should I query? I need to query these three tables in order to get the right answer. You observe here that I don't select anything from departments and I don't select anything from locations. I only selected one item from the employees, basically count of employee IDs. That's it. Okay, that's what I'm interested in. But nevertheless, I'll list these three tables because I need these three tables, because information is scattered across these three tables. And here I specify the conditions. I'm saying locations country ID should not be US. This is a valid question, right? Also, I'm saying that location ID from locations should match location ID from departments. That's the condition. And at the same time, employee department ID should be equal to department ID. Essentially, this condition should be valid, three conditions. And if I run this statement, I will get the correct answer. Works? Okay, good. Let's move forward then. So you have to know joins quite well, because this is, again, this is the second question you'll be asked on the interview. So in order to know it, you have to practice it. So how you create a join, you basically start to list the tables which you are going to query. Then specify logical conditions, and then specify what exactly you are looking for. Okay. So this should be rephrased, actually. It's too much information here. I think we can skip that. If time permits, we'll do that. Okay, but if not, we'll skip it because it will take much time to do. But these are valid questions which you can ask, and this information is scattered across several tables. We should be able to query that. For example, how much is the top salary which employee 101 can earn? We have to query two tables: salary jobs, right? Jobs table, and employees table. Because salaries are listed in jobs, employees are listed in employees, specifically employee 101. Where IT department is located, this is pretty much closer to what we already covered. we have to query 3 tables. Employees, actually 2 tables, departments and locations. Okay. How much money employees working in Great Britain are making combined. We have to query employees table, departments, and locations. Okay, 3 tables again. So next thing, bless you, next thing which we are going to cover are views. Okay, what happens is that views are virtual tables. And any questions about the joins? Definitely that requires a lot of time. I cannot cover within 5 minutes, 5 hours. Okay, you have to practice it. Okay, basically I'm showing what the join is and how you basically construct it, but it does not mean that you are experts now. Okay, you have to practice it. And unfortunately, or fortunately, they ask on interview, depending whom you ask. They ask that on interview question. If you don't know joins, it means that you will fail on SQL interview, most probably. Okay, more than most probably. Okay, so the book covers that. So if you're interested, just see me after the class. That's why I bring book. I usually don't bring books for other classes, but this class is a special one because we don't have much time. But you definitely need to know it because this is a very important subject. Okay. Okay. Anyway, let's move forward. Talk about views. What view is a virtual table, which is a result of the query. For example, if I go and execute the statement, this one, for example, select star from departments. Okay. When I execute this statement, I will actually virtually recreate departments table, right? This is not a table itself, it's a result set, okay? But we can imagine that we can look at this result set as a kind of a virtual table. And this virtual table is created when this statement is executed, okay? You may say, what's the big deal? We have a table and then we're creating some virtual stuff which is exactly the same and we don't gain anything. But let's assume we have a little bit more complex select statement saying where location ID equals, for example, 1700. Essentially, I'm getting the result set for departments with the location 1700. Okay, if I execute that, I'm getting again this table, but this table is not the full table itself. It's kind of a subset, of virtual subset of the original table. And assuming that 1700 is located in the UK, I'm saying this is my table for departments located in the UK. Okay, and I may call it that way. I'm saying this is my UK departments virtual view. So what's good with this is that instead of making complex queries, for example, if you like to query who is a manager in department, for example, department in London, for example, or give me a list of managers in department, you don't need to query the whole departments table. You can query this subset. Okay, so it makes a syntax simpler, but you don't get performance gain because this table or actual view does not exist. In order to create the view, you have to first execute this statement, and then after that, on top of that, execute something else. Okay, but syntactically, the statement becomes simpler. That's why they call this result set as a virtual table, virtual one, because they don't exist physically. And this statement is laying behind this virtual table. Essentially, all virtual tables have some select statement behind them. Okay. They allow us to simplify select statement. For example, if you'd like to query additionally this result set, you are querying against the virtual table. Instead of saying select star from departments where location ID equals 1700 and manager and, you can say select star from UK departments, something like that, virtual. Okay, so your syntax becomes much simpler. That's the driving force behind the tables. For example, another example is that if we like to create a virtual view, and then, for example, if we like to make Christmas presents to these employees in the Bay Area, we can simply query the, say, like this. For example, select star from local employees V. Okay, this virtual table will be called local employees V _V. All virtual tables by nomenclature, they are, I mean, this is by coding standards, are coming with the suffix v, which stands for virtual view, okay? Just view. Underscore v, they are views, okay? There's no physical tables behind them, but the select statement, which is behind them. Sorry?
How we keep this table?
You can create that. You can go ahead and create that and saying this is my view, local employees view, and you have to also provide SQL statement behind this view, because without SQL statement, I mean select statement, this view cannot exist. For example, this is answering your question. For example, if you like to create, you can go to object browser and the views. You can create a view we call local employees v, and the query which is behind this local employees v will be this one. Select first and last name from employees where phone number like 650, for example, something like that. Okay, and in this case, next time you like to query only local employees, for example, who is getting an average salary among local employees, who is started first, started last, and so on, millions of the questions you may ask, you can query these local employees as if it's a table. Okay? Because there is, for SQL statement, it doesn't matter. You can say select star from local employees v. Okay? And then you'll get everything for all information about the local employees. Or you can say select first name, last name, or select phone numbers, or select the IDs from local employees underscore v. Okay? You can create that because user HR can have, has enough privileges to do that. Okay? You can update views with the update statement, but underlying table is unchanged because this is all virtual. Okay? And you don't get any performance gain. Okay? It's basically simplicity of the statement which you obtain. We also have another concept which, it's basically this statement can be simplified to this one. Okay? And in reality, you can actually simplify much complex statements to this more simpler one. Okay? So in addition, we have the next concept is a materialized view, which is actually a table, but it's a subset of a real table. If we think about the bank, remember that the bank database and the table is growing drastically with the new purchases made. Then with the time, this table becomes bigger and bigger, and bank actually started to think about the possibility to improve the performance. And then they invite DBA and they're saying, you know what, can you improve the performance? We like this table will act faster because according to the regulations, we are mandatory. You have to provide the feedback within, say, 45 seconds. Okay, and if the performance is not good, we cannot actually guarantee that. So DBA started to analyze the load and the database function, how the database functions, and then he realized that there are certain number of users or bank customers who require a lot of attention. These people who are making a lot of purchases, these people who are losing the credit cards more often than everyone else, and then actually they consume a lot of traffic, a lot of load. Okay, so it would be nicer if we get these employees, bank customers. If we get these bank customers and put in a separate table, and let direct the load into that separate table. But at the same time, keeping them in the main one, because we don't like to delete that. We don't like to replicate the tables, duplicate that. So that's the concept is called materialized view. It's basically a subset of the main table, but we like to actually redirect the load to that subset of the table, materialized view, and as such, we like to gain performance, get performance gain. That's the purpose of the materialized view. It's a real table. And that allows to increase the performance of the database. Okay, so and then you realize that we should be able to distinguish between views and just materialized views, and this is the suffix is MV, materialized view. Now, materialized views should be synchronized with the main one because they are real tables, and if you don't synchronize them together, they will be out of sync. Okay, so you should regard it as a normal table, but it's as a subset of some other one. Okay, that's what it is. Okay, so that's the concept of materialized view. And then may ask the question, what's the difference between view and materialized view? Should be able to answer that. Okay. And then if you like to create a materialized view for in the database, you'll get an error. Okay, this error because you don't have sufficient privilege. Or actually, user HR does not have sufficient privileges. But if you log in as a system, if you're on a personal laptop, you can do that. Okay. So because user system has all rights. Okay, that. So next thing is the transactions, which very popular and should be able to understand that, and that's what we are going to this auto commit button. Okay. So what a transaction is a series of series of statements, SQL statement, which should all pass. What means that if any of these statement fails, we regard that all transaction fails. Okay. So in order to say transaction pass, it should mean that all statements passed. Okay. We say if transaction passes, then the last statement we execute is a commit, which makes the changes in the database final. If one of the statements fails, it means that we have to undo results of all statements in this transaction, right? So that's why we have to issue this command rollback, which actually undo all statements back, okay, reverted back. So what the auto commit button does in your browsers, it actually automatically issues this commit statement after each statement you execute. Okay, update, delete, whatever. So that's why it's dangerous, because it automatically made it final. Okay, you cannot undo it. But if you remember, I unchecked the auto commit, and after the updated Diana Lawrence first name, last name and email address, I issued this command rollback, which actually undone all my changes. Okay. This is possible. This is commit and rollback, and they are very closely related to transactions. That's the whole point of transactions, where you as a QA engineer can use this very easily. For example, let's assume you do some testing, and that testing involves a lot of changes made in a database, but you don't like to change the database permanently. So in that case, you can run your automated test cases or manual test cases. You can do it all day long, and finally at the end, when you're satisfied with the result, you tested something, you say roll back. And database will restore the original state, which is a very nice feature, right? You don't need to create a copy of the database, make a backup copy, and then restore it. Okay, this rollback will do it. Okay, or if you're happy with your result, you can do commit and then make these results final. Said that.
How do you specify the point to rollback?
Actually, it's settings of the database. You can set how many actions back it remembers, okay? But essentially, by default, it goes to the first statement after last commit, okay? You do commit, and then it starts counting from that last commit, okay? But how many actions it remembers, it's actually property of the database. You have to ask DBA how to do that, set that up, okay? I never experienced a situation when I need to think about that, but probably I did not so many just to hit the limit. Okay, but that's a database DBA, the DBA question for DBA. Okay, next thing is example of a transaction is credit card purchase. When you make a credit card purchase, there are several actions happen behind the scene. First of all, you send that information to the bank, and bank verifies that this credit card number is valid. Okay. Second, it verifies that the purchase which you like to make matches your credit card type. For example, having corporate credit card, you cannot go to the jewelry and buy jewelry. Okay, this kind of transaction is prohibited. Okay, the bank does that. Okay, so next thing bank looks is just an amount of purchase. Can you do this purchase or not? Is this enough credit you have to make this purchase? And the last thing is actually, maybe next thing is just saying, is this vendor is authorized vendor or not? Okay, and then it may also check against the fraud pattern, something like that. And the last say it's actually arrest this sum which you like to purchase, make an arrest, and then some other checkup, and finally saying, okay, this sum is actually your credit card is charged that sum. So basically, you see that there are a lot of actions going behind the scene. And if all actions is passing, then we say this transaction passed, you make your purchase. But even if single one fails, for example, let's say this point of purchase is not a valid one, okay, it's kind of fraud with that, or fraud detector saying, you know what, this looks very suspicious, or credit card expiration date is reached, or there's not enough credit available, whatever. There might be multiple reasons. But if any of them fails, then we say, you know, this purchase cannot be made, right? Basically, transactions fails, and then we roll back all changes we made in the database, the rest of the amount, and so on and so on. We basically rolled back, okay? That's example of the transactions. You should be able to, I mean, they may ask you what the transaction is and how you define that, and definitely you have to mention the commit and rollback, what the role of commit and rollback have in transactions. Next thing is the triggers, which I mentioned briefly, is basically is a mechanism which allows to automate some actions, and then in the case when certain event happens. For example, every time we add a new employee to the employees table, then we like to trigger some actions, sending email to the IT, sending email. I work in the company. When you started that company, the very next day you accepted the offer, they send you flowers, okay? So this process was automated, okay? It's not done manually. Okay, next is we're going to cover interview questions, and if time permits, we're going to the joins, okay? Because I don't like to leave that topic. So SQL, what SQL stands for? It stands for Structured Query Language. How you select all records from table? Definitely you execute this command, select star from the table, okay? Table name. That will retrieve all fields. If you're interested in a specific fields, definitely you have to list them separated by comma, as we did many, many times. What is a join? A join is a process of retrieval of pieces of data from different sets, tables, and return to the user as if it's one table, located in one table. Basically, grab information scattered across multiple tables in one statement, okay? Because you can retrieve this information in several steps, but that's not the whole point. Point is just to have one statement, okay? There. How do we add records to the table? Definitely you have to use insert into the table. This is an insert statement, right? You're inserting something into the table, okay? And then you specify values. For example, they may say, we have a table which consists of first name, last name, and the date of birth. Write a statement to insert that value into that table, okay? Should be able to do that. How you add a column to a table? You alter table, but we haven't covered that, so if you don't answer that question, that's okay, because this is actually data DDL, you alter the table, you have altered the tables, the database structure, okay? That's okay. How you change the value in the field? Definitely you have to update and then specify using keyword set, specify the field and then value. This indicates this number is 200, number is field name, 200 is a value. In our case, we use first name is Göz, right? Remember? Yeah, that will be first, field name and the value which you are going to put in that field, okay? And then you specify also predicate, because otherwise you're going to update the whole table, which is not the purpose in most cases, okay? Or this case, for example, update name table, set status enable, where phone is this one, okay? For example, if I have table with field status, then this is the correct statement, okay? Again, they may ask, say, you know what, we have a table with these fields. You have to be very flexible and then be able to immediately write this statement. Okay. So what does commit do? We just cover that. It basically make all changes which you made in a database permanent, okay? DML stands for the data manipulation language. We haven't covered that. This is abbreviation. If you don't know that, that's okay. So what is a primary key? It's a basically column or field of fields. Not only it might be several fields, a combination of fields, which makes the records unique. Okay, basically keeping the data integrity. Okay, in most cases that's one field, but that's not the limitation of that. So in some cases you have two fields, two primary keys in the table. What is a foreign key? It's actually it's a field that it's links to, in one table it's a primary key, and the same values appear in the second table, but they are not unique anymore, okay? That's what a primary and foreign key definition of primary and foreign key. What is the main role of primary key in a table? The main role of primary key in a data table is to remain the internal integrity of the data table, basically keeping the data integrity of that table. Can table have more than one foreign key defined? Yes. and we actually have that table in our database. That table is locations. Okay, locations table have one foreign key is wait a second. Departments. Departments has a locations, and no. Let's have a look. That's a good question, right? In order to do that, I'm saying describe departments. Department ID is a number. Let's see, foreign key here, foreign key here. So we have manager ID is a foreign key which points to the employee table, but yes, because it's called manager ID, but that's a value for employee ID and employees, right? So employee ID and employees is a primary key, so that's why it's a foreign key here. And we have also location ID, which is not a unique here, but location ID is unique in the locations table. That's why we have, so you see it says foreign key and foreign key. We have two foreign keys here. Okay? Foreign key here and foreign key here. And you see that these foreign keys can be nullable. There is no requirement that it will be unique and definitely should be specified. They can be nullable. But if it says primary key here, it cannot be nullable. Otherwise, the whole meaning of the primary key is compromised, right? So this is the department ID is a primary key here. Okay? So we may have several, it's pretty common to have several foreign keys in a table. Said that, Boolean, we didn't cover that, but basically we have 1 or 0 in Oracle. Okay, it may differ from database to database, but it can store only one of these two values, either 1 or 0. Okay, in a Boolean database. If you define a field as a Boolean data type, you can store only one of these two values. Same with the byte. Byte is storing simple character. One single character, and then up to 0 from, ASCII code from 0 to 255. Okay, nulls, what null is basically a value which tells that the value is not specified. It's a placeholder, okay? And if we need to get hold of these null values, we have to use operator is null or is not null. Okay, we covered that. What the normalization? The process of database and table design. That's what it is. That's the definition of normalization. Trigger, we covered triggers, so no need to go deeper in that. How one can select a random collection of records from a table. This is actually also database specific. In Oracle, you can select the one of the following. So you can say select star from employees, sample 10. What 10 means here is percent of records, okay? Yeah, what it says, 10% of randomly selected records will be retrieved. If you have huge database and you like to see what data it contains, but you cannot run basically select statement, simple select statement, you can say sample 1. You get 1% of records. In that case, you'll get visually you can inspect that. Sample should be the last one, okay? Or you can also specify how many records by number. For row num, it's a special keyword specific for Oracle. You have to say row num less than 5. In that case, you'll get 4 records retrieved, okay? Because each individual record is numbered, okay? You cannot guess that number, but you can say, this row num less than 5. In that case, you'll get these 4 records, okay? But that will not be random, okay? So said that, again, this is specific to Oracle. They may ask questions like this. For example, if I execute this statement, which record will be retrieved? One of 4 answers.
Jackson C.
Yeah. Correct, because only Jackson matches this condition. one character at the beginning, but the second character should be capitalized A, okay? And then followed by any number of characters, including 0. So only this one, the C, satisfies this condition, okay? So analyze accurately this so distinct, we didn't cover that, but we used once, right? What the distinct is, it basically retrieves the distinct values for that given field. Alternatively, you can use unique, but unique is going to be obsolete, so it's better to stick to distinct. Okay. In this case, for example, let's assume we have a tables which lists the student names and the cities they came from. And I like to know the list of cities. I get list of cities, but unique values, not the repetitions. So we can use distinct to eliminate duplicates. In that case, we'll get distinct cities from students. Okay. And then definitely you can use order by to list them alphabetically. DML and DDL, the data manipulation language, the data definition language, we skip that because this is a part of the SQL. Basically, SQL language is split into several parts. Okay, one part is just manipulating the data, another part is manipulating the definitions. So we skip that. There is no. If you don't know about this, that's okay. So skip it. Yeah, for example, this is also interview questions. Say, for example, let's assume we have a table which has a first name and last name, and then salary, and then given number. In this case, that will be it. Say, select first name, last name, salary, and row num. Because row num is internally numbered records. You don't need to number them specifically. Basically, you retrieve that. Okay, so that will be uniquely numbered from instructors. And then we have the table instructors. Okay, again, row num is specific to Oracle. Said that is the where clause must appear always before the group by clause in the select statement? Yes. So group by should be one of the last statements you have. For example, as shown here. Select and from are mandatory. The rest are optional. For example, depending on your goals, what you like to do. So again, we'll skip this. Describe SQL commands. If you use 2 dashes, that will be effectively commenting that line. It's not multi-line. Multi-line is single-line comment. Difference between truncate, delete, and drop commands. We covered that today, so you should be fresh in that. Okay, still remember that. If you don't remember tomorrow, just open that slides and read it. Okay, this is the explanation of it. Okay, this is slide 110. And the last thing, they may ask the question about the dual. So it says select the end from dual. If you execute this statement, you'll get end printed. Okay, what happens is that the end is literal. We don't have the end anywhere in the table defined. Dual, but we cannot simply say print because SQL language does not understand print. Right? The only statement it understands is select. So if you like to print something, you have to do select. But if you select something, you have to specify the table, right? But we don't have any table which contains literals, right? So we have to create kind of dummy table, and this dual plays a role of dummy table. Okay, you can do anything with it. Okay, provided the statement is correct, it will do anything. For example, if I like to retrieve the current date and time, which is not specific to any table, I can use dual. I can say select sysdate from dual. And if I execute that, you'll see that I get this value with the current date and time from the dual. So it's not necessary dual is bogus, but you know what, I need to use some table. If I substitute dual with some other table, I'll get the same result. But this table always exists. You don't need to query the database and find out what tables you have. You should remember that this table is always there waiting for you. Any other questions? Okay, I realize that I overwhelmed you with information, okay, and that's definitely we should have more lessons on SQL, but unfortunately we don't have it, okay, we don't have that luxury. So it means that you have to practice at home. Practice, practice, practice until you know SQL like this, okay? Because this is very important, and they ask on the interview, and they ask to during working day, okay? It's basically you have to have working knowledge of SQL, okay? That's pretty much it. You are going to have 3 more classes on technology, which is 1 virtual machines and 2 networking, okay? So that will be pretty much of technology class.
It is